Okay, now, again, my point here is that you have a proportionality, so conclusion, first of all, I'm going to let alpha, it's not a real good looking alpha, but we'll use it. We're going to let alpha and I didn't write with respect to time, but this is with respect to time. To say that that is directly proportional to cosine theta is to say that A equals K cosine theta. Does that make sense?
Yeah.
You know, being proportional to something is kind of transitive. Well, it is transitive. If this is proportional to that and that's proportional to the other thing, then this thing is proportional to the other thing. Okay?
Yeah.
Now that's just a little background. I haven't explained the physics, but I've given you a picture here that leads to the physics explanation. And we're not learning the physics, but I'll give you a little idea of it just so you have a context. Okay, so alpha equals K cosine theta. Now, another thing, angular velocity is the rate of change of theta with respect to time. Just like velocity is your change in position with respect to time, your rate of change of position with respect to time, angular velocity is the rate of change of angular position with respect to time, and angular position is the angle. Okay? So that's why we use the word angular here. And those are good words to know because most of you will end up taking a physics course sometime before too long. Okay? At some point, and the place where people start to get freaked out in physics is when they start dealing with angular quantities. Okay? So if you've been exposed to the idea of angular velocity and stuff like that, as you are in this course, it's going to be very helpful to you later on if it kind of sticks. Even if you've forgotten it, you're going to have those neural circuits and it'll come back to you when you need it. Okay, well, with that aside, we don't have to understand any of these meanings at this point. We just have to understand what a rate of change is. Okay? Because the condition I'm giving you now is the proportionality constant here, I'm speculating, is 1,000 radians per second squared. And theta equals 1.4 radians and actually say this. I'm going to say angular velocity is 0.1 radian per second, when theta is 1.4 radians. Okay? Now, from what I've given you here, you can figure out a calculation scheme that will allow you to figure out how fast this is moving every millisecond, and where it is every millisecond. So we're going to proceed with that. Okay? We want to think about that for a second, so I'm going to cut the video, and we're going to talk about that just a little bit.